Have you ever pondered the mysteries of antimatter and its significance? It's an intriguing subject that plays a crucial role in modern physics. Imagine a world where everything is exactly the same, but charged differently. That's the world of antimatter for you. It's a form of matter composed of antiparticles, mirror images of the particles we're familiar with, but with opposite charges. For instance, an electron, a negatively charged particle, has an antimatter counterpart known as a positron. This positron is identical in mass to the electron but carries a positive charge. Now, what happens when matter and antimatter meet? An extraordinary event known as annihilation. They eliminate each other, releasing a massive amount of energy. This annihilation reaction is remarkably efficient, converting nearly the entire mass of the particles into energy. Yes, that's right. It's a real-life demonstration of Einstein's famous equation, E equals mach squared. But where does antimatter come from? It's not something you'll stumble upon during a stroll in the park. Antimatter is exceptionally rare in the universe. It's typically produced in particle accelerators or through high-energy interactions involving cosmic rays. Antimatter is not just a fascinating concept, it has practical applications as well. It's used in various scientific and medical applications. There's potential for it to be used in energy generation and propulsion systems. However, the production and storage of antimatter remain highly challenging and costly. Could antimatter be used for destruction? It's true that antimatter holds an immense amount of energy, but the notion of an antimatter bomb is purely hypothetical. The technical difficulties and challenges associated with producing, storing, and containing antimatter make it highly impractical for use as a weapon. Moreover, the cost and resources required to produce even a tiny amount of usable antimatter are currently prohibitively high. So where does antimatter find its place? Its practical applications are more likely to be found in medical imaging, cancer treatment, and basic scientific research. The portrayal of antimatter as a weapon for now remains in the realm of science fiction rather than reality. In essence, antimatter is a mirror image of ordinary matter with the same mass but opposite charge. When it comes into contact with matter, it results in an annihilation reaction, releasing a vast amount of energy. Despite its potential, the production and storage of antimatter are fraught with challenges and high costs. Its practical applications are likely to be found in medical and scientific fields, while its use as a weapon remains a concept of science fiction. So, the next time you think of antimatter, remember it's not just a science fiction trope, it's a fascinating part of our universe.